Okay, so today we're going to try and make a 4x4 matrix. I got the idea from Nick Gammon. I mean, it's a fairly common idea, but Nick explains it pretty well. And when you draw it out, you have either side of a momentary switch. So you have 32 for 16, 2 times 16. And each side of the switch goes into a diode and onto a common rail, and that becomes the row input. And then you connect each of the other side of the switch up to a pull-up resistor, and that goes up into the column. And after thinking about this a bit, I think we can do it like this. So I've tried to draw it here. So the idea would be that we put the pin going up in the air into a substrate and solder that on. Meanwhile, we stick a diode into there facing down, and then the rows come across like this, and that should get us that part. And then we connect a wire, hopefully the resistor wire will reach across the second side, and that will give us the pull-up resistor. So let's see if we can work that out. It's some of this little board here. So we've got 8 by 4, and what we want to do, and then we've got another piece of board like this. Okay, and that's going to go which around that way round, and the idea is that the diodes will go on the bottom of there and then into these rows, like so, effectively. And then we've got one layer left to pull off the inputs. Yeah, so that's the plan. How easy it's going to be to make, I don't know, but let's give it a go. So I think I'm going to try it like this. I'm going to loop that round the back there, and then take that in the front and dab solder across there. So let's give that a go. So you see I form it round one of those first, and then I can transfer it onto the jig ready for soldering. Right, so those are the 4 resistor leads going, and they're like snotted onto a column or a row as I look at it here. And it looks to me like I'm not touching anything. It's not my best piece of soldering, but it seems to do. Okay, so I put a bit of heat shrink down there. The simple reason being that I could convince myself that the blue can touch the black as best I can see without it touching the silver of the other pin. So the idea being that that at least has gone through there. So let's put the top bit in. It's quite a tricky bit. You just need to sort of put the wires through 4 at a time. I'm using every other hole because that's what they're doing. I bent each row in, or column, which way you look at it, one at a time, put it in next one. And now I've got to pull this down and through, get it to sit on the heatsink. Okay, so we've got the 4 resistors coming down into tracks there. So 4 independent tracks, which will go along there. So we can put a end piece there to connect them. The, where's it going? Yeah, the resistors come along this line here. Then we have the diodes pretty much, you know, with some heat shrink in their places. They're going to be tacked in there. And this last column there can take the 4 row column. Now I've got to be careful which is which, because I'll be honest, I don't actually know at the moment. I just know that let me see if I can find something to point. This resistor will be column 1. Get it right. That would be column 2, column 3, column 4. Yeah, column 4, 3, 2, 1. And then this will probably be like row 1, 2, 3, 4, but I'm not absolutely certain. Anyway, I'll work it out with a multimeter later. Again, not my best soldering, but I think that's okay. I don't see any of those tracks touching. So this should be the diodes coming in. This should be the resistors coming in. So I've now got to stick some, I guess, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, let's put an 8 output on there. So let's do that now. So in an earlier video I said I had these ones which are better quality than the other ones I've got, which I think are in this box. No, they're in another box I've got somewhere. So I'll give this one a go. Another benefit of these longer, higher quality ones, I made a slight mistake. You see, I'm out by one. If you look there, I put the copper into the next one, so I can just splay that a little bit. Yeah, it's going to look a bit gash. Actually, it raises it up to a similar height, and all's well that ends well. So I'll just push that through enough, and then solder that in place, and it sticks out a bit. Oh well, tough luck. Yeah, that's about it. Now, again, I don't want to say much about my soldering because it's pretty crap. You see how much better it is on those last ones there? It's just a better quality component. And this cheaper stuff I get from a well-known country is pretty useless. So I think I'll go back to buying the European British stuff, or they get it from the same place but they have better quality, I suppose. So that seems to be it. So that should be my little switch or matrix made up, waiting to get shorting pins across there, so I can put some DuPonts on those cables and try and get it running with the Arduino stuff that Nick Gammon wrote. Okay. Oh, hopefully it will port to ESP if I use ESP. I think it should. It's pretty much the same concept. Okay, so we take Nick Gammon's code here, which I got from his website, which is here, Nick Gammon keyboard decoder. So you can git clone that down. And the only change I made, I'm using a Leonardo, is I changed the debounce time to 1000, like 1 second, and I put debugging true on. He puts his row pins on 6, 7, 8, 9 and his columns on 2, 3, 4, 5. That's what I tried to do here. So there's my Leonardo, there's my array, and when I do it that way round, it seems that that's the top. Something to point with. This top here in my wiring is the highest one, and this is the lowest. So, oh, one more thing. When I do the compilation on my Leonardo on this latest version of Arduino, I get this kind of crappy thing. So let me just do it one more time. I'll push the upload button there, and you see it starts. Says it's uploading. You get this stupid error, but in the bottom it says uploading and then done uploading. So now when you go to the serial monitor, which you have to set, serial monitor, which you have to set the 1152 board, now you see it says no key press. So we've got one wire currently going in here. This is the bottom left. So when I push this, you should say that key 0 has been pressed. And it has down, and it stays down. Nothing happens because I'm holding it down. I let it up, and now it tells me it's up. So let me pause and put another switch in the matrix. Okay, so I've gone across one and up one. If that's 0, then that would be 4, 5. So let's see if this is number 5. Hang on. Yep, 5 up, down, 0 up, down. Yep, and let me try and hold them together and push them at the same time without interrupting the Arduino. Hang on. Put them on top. Ready, steady. Push them both down. Let go. And what does it say? 5 and 0 is that? Yeah, so 5 and 0 is down. It tells me 5 down and then 5 up. Yeah, so that's measuring them individually or together. Yep. So that's working. So the little array works, which is neat. So now I have 8 pins giving me 16 inputs total. Obviously, I'm going to speed this thing up because a 1 second delay is a bit slow, but it's just for debugging. Yeah. I'll check the rest of this array to make certain that they're working. I think there's a better way of doing it. When I did it before, I put these in situ in a controller, into a header to hold them together. And actually it'd be better to separate them differently. It'd be much better to make a curly tail for the diode lead, push that down and solder that on every other pin of an 8x1, and then put them together and solder the leg for the resistor. And of course it would be much better not to make the mistake I made here of accidentally moving. I didn't count the pins. Yeah, if I'd done it better, I wouldn't have had to bend this output pin, which for the life of me I can't see where it is now. Oh, there in the back there. I wouldn't, in the front there even, I wouldn't have had to have bent that leg there in that, because if I'd have just moved these resistors over one, it would have worked. Anyway, this seems to be working quite nicely. Thank you, Nick Gammon, and I've got an input code now.